Yes. So yesterday we were talking about mean median mode, right? And that was, we call it as measure for central tendency, correct? And what we said is uh, that those numbers, okay, determine best set of data. Okay.
Yes.
Uh, okay. Now let's say um, um, let's say I give you uh, let's say we'll look at two businesses. Okay. Okay. Now both these businesses, okay, they have average. We'll talk about car distribution center, car dealership. Okay, and where
Mm.
you go and buy car. Okay. Now both
Okay.
these businesses, they have average time of delivery of cars as, let's say, 30 days.
Okay.
Okay. So does it mean that both of them are equally good or equally bad?
No,
Okay. Why is that so? I'm talking
we
from
can't
the
say.
delivery point of view only. Okay.
So with this delivery date, we can't say it is good or not. No,
No, both are
it's depend
delivering
on
on average 30 days, no? So why no?
the delivery partner. Ah, yeah. So for both are same only.
Both are same only,
Yeah.
or both are not same?
He's like delivering a car in 30 days, and other company also delivering a car in 30 days only. So
Uh-huh.
from the point of view of delivery partner, it's not make any difference. Both are same.
Okay. That's what you think
Mm.
so?
Mm.
Okay. Now, see, when I say that the average is 30, okay, it means that values will be less than 30, more than 30 also, right? Now, let's say one company delivers, okay, within 28 to 32 days. 28 to 32 days, right?
Okay.
Now, when it
Mm.
delivers between 28 to 30 days, okay, that is plus average plus or minus 2 days. Okay. Another company delivers within 5 days also sometimes and within 60 days also sometimes. Okay. Now, which one as a customer you will like? See, average, if you take
Ah,
both, the average will come to 30 days,
right.
right? But one delivers within 28 to 30 days, one delivers within 5 to 60 days.
60 days.
Okay. Whom will you trust more?
The second one, जो 28 to 30 days में deliver करेगा, because where I have less range.
So,
Hmm.
less range, so
Second one. So I know whether it is 28 days or whether it is 30 days. It's not like that
correct. So here it is more
from
predictable,
5 days to 60 days.
right? I'll tell you, see, sometimes I'll tell you that we'll have class at 4 p.m. Sometimes I'll tell you a class at 10 p.m. Okay. And I'll say, see, average is 7 p.m., isn't
Yes.
it? So sometimes we'll have class at 4, sometimes at 5, sometimes at 6. Will you like it?
No.
No. Right? You'll say that, sir, you whether keep it 4 o'clock or you keep it at 10 o'clock. Where do you want to move around? Sometimes 5, sometimes 6, sometimes 8, sometimes 9. Right?
Yes.
Right? Because we all want predictability. Okay? We don't
Mm.
want, okay, we don't want which is difficult to predict.
Yeah.
Okay? That's why, okay, even though in both the cases, average is 30, but people will tend to go because, see, let's say you book a car, okay, and they tell you 30 days. So you say, okay, 30 days on average. So, maybe you don't have money. You are thinking
Uh,
to, get money from by
Arrange.
selling some
Yeah.
share or, selling some mutual fund, and you are planning all those things. And then next day you get a call that your car has come You pay the
Yeah.
money and take it today, or you will not get it for next 3 days,
Yeah.
right? So
Right. Right.
it is difficult, right? So even early is also very difficult, because once I tell you that, okay, 30 days, mentally you are prepared for 30 days.
30 days only. Yeah.
Exactly, right? So even if they give you into 5 days, 10 days, okay, you may not like it. Okay. So
Hmm.
point here I'm trying to make is that we all love predictability.
Predictable
And that's
things.
why
Yeah.
our mean and median alone cannot tell how good is our
Hmm.
process. And we will have to talk
Okay.
about range, as you
Fine.
said. Okay. Um,
Hmm.
Okay, so we have to look at other aspect also, other metric also. What are those metric? One metric is range, as you said. Okay, range is maximum minus minimum. So if you look at these two data set, okay, here range is maximum value is 100, minimum is 5. So range is 95 for data set 1. And but for data set 2, range is 79, 100 minus 21, right? You would prefer the one with less range, right? You'd prefer one with less range, isn't it? Because less range, as you only said, right? Less range means more predictable. Okay, but sometimes range might have outliers. That means, okay, let's say most of the values are between 5 to 20. Most of the values in data set 1, okay, 5 to 20, one data is 100. It can happen, right? One day, okay, if you're doing class for 3 months, 4 months, it's possible 1 or 2 days I can be very late, right?
So,
Just because I'm late for one day, okay, it doesn't make me bad, isn't it? If I do it continuously, regularly, then it is bad. So your data might have outlier, one outlier 100, but rest of the data within 5 to 20. And this, like, let's say, data 1 is evenly spread from 5 to 100. Data 2 is 5 to 20 only. One data is 100. So because of one outlier, your calculation will give you 95 and it will look bad, right? So outliers are something which are, see, generally outliers are which is much different than the most of the numbers, right? Or
hmm.
much different than regular data. Okay,
Yeah.
either it could be very high or it could be very low. And also we say outlier because that is an outlier behavior. That means it is one of case, it's not regular. Just because one
Hmm.
data is outlier, your entire analysis will go bad. No, 1 or 2 times we have to give benefit of doubt, isn't it?
Yeah.
So that's why we prefer interquartile range. We say that, okay, range sometimes cannot handle outliers. Okay, just like
Right.
your mean cannot handle outliers, we prefer median. Similarly, range cannot handle outliers. We prefer interquartile range, or IQR. So what it says is, okay, you divide the data set into 4 equal parts. Interquartile. Quarter means 1/4, isn't it? So that's how you have to remember. Interquartile. Quartile means what? Quarter, 1/4. So,
Okay.
okay, so you are dividing the data set into 4 equal parts. In median, we were dividing data set into how many parts?
2 parts.
2 parts, yes. And interquartile, we divide the data set into 4
Four
parts.
parts.
Okay, so let me share my screen once. Uh, where is this gone? Yeah. So what we say is, let's say if this is your data, it says first you divide the data into half
Hmm.
using
It's
median.
it's medium.
Okay, then again divide this half again into half using median of this. So take this as
Median of
maximum, and
this.
yeah, and then
Okay.
again median of this,
Median of this. Okay.
higher side also.
Hmm.
So first you take median of the entire data set, then you take median of the lower half and median of
Hmm.
the upper half. So what we have done, we have divided the data set into 4 parts. Okay,
Yeah.
And what we are doing, okay, so first let's see what we call them. Okay, this is your minimum value in the data set, right?
Yeah.
This is your median value, correct?
Yeah.
This is your maximum value, right?
Maximum value. Hmm.
Okay. Minimum value is also called as quartile 0. This is also called as quartile 1. This is also called as quartile 2. This is also called as
Quartile
quartile
3,
3 and quartile
4.
4. Okay. Quartile 0, 1, 2, 3, 4. Interquartile means divide the data set into 4
4
parts.
parts.
Okay. And what it says is ignore this quarter and ignore this quarter. Instead, focus on this. So range is your Q4 minus Q0, right? Range means
Mm-hmm.
what? Maximum minus minimum, which is
Minus.
Q4 minus Q0. Okay.
Yeah.
IQR becomes what? Q3 minus Q1.
Ah.
Okay. IQR is Q3 minus Q1. This is your IQR. Now,
Okay.
IQR will help
Minus.
you to understand, okay, data set even if they have outliers, because we are removing the outliers and instead
Mm.
focusing only on middle half data.
Middle of data. Yeah.
Right? In a previous company, I used to work on financial data set, okay, and we used
Mm.
to calculate industry average of gross margin, operating margin, inventory turn, etc. So we used to download data from entire globe. So when you download data from entire globe, all the public companies of some 50 million, something like that, we used to get about 34, 35,000 companies. Okay. Now, when you start taking average, okay, of entire industry or say a particular domain, let's say, retail, there will be some company which will have very high value, right? There will be some company which will have very low value, right? So what we did was we removed, if you take 100 companies, if there are 100 companies in the data set, you remove top 25, remove bottom 25. You take the average of middle 50, that will give you the industry average.
Yes.
Okay. So you work with middle 50 only. Don't work with entire data set, because data set, of course, will have outliers.
Yeah.
Okay. This is called
Interquartile.
interquartile. Okay. So similarly, okay, now similarly, you can create something like um, 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 this is quartile. Okay. So this is what we just did is created quartile, and then interquartile range is Q3 minus Q1, right?
Mm.
Now, what we did was, okay, I mean, not what we did, what we can do from now is we can create other types also, like, percentile, decile, okay? Percentile means, centile means per 100, right? So when you write, you know, GATE exam, CAT exam, or GMAT exam, you get percentile.
Mm.
What is percentile? Percentile means per 100. Quartile is per quarter,
Quarter.
right? So, in that case, what we do is we take the data set, okay, and you
Mm.
divide into 100 parts, okay, 100 parts. So when you say you got
Okay.
99%, what does that mean? 99 percentile means there are 1% per people above you. So if there are 100
Yeah.
people, your rank is second rank.
99.
There's only 1% above you.
Okay.
1% above you. When you get 99, that means out of 100, there's 1% above you. If it is
Okay.
1000, that means 10 people are above you. Rank is 11th.
Hmm.
If it is 1 lakh, then how many people are above you?
1,000.
1,000? Yes.
No. हाँ,
Yeah, yeah, yeah.
1,000.
1,000. Okay. 2 zeros you remove,
Hmm.
right? So, yes. And there will be, I don't know, like, I'm sure there will be writing more than 10 lakh people would be writing CAT exam, right? So, 10
Yeah.
lakh means your rank is around 10,000. So
Hmm.
sometimes even if 99 percentile also, you may not get into IMs. Why? Because, you know, you got 99, you are in top 1%, but that 1% itself is too big.
Yeah.
Okay. So this is what we say percentile, quartile, decile means per 10. You divide data set into 10 parts. Okay.
Hmm.
Let's move on to our topic. So this is what we call IQR, and IQR is leaving the 25% both the side. Q3 minus Q1 is your interquartile range. Now this is talks about how to calculate median. You know how to calculate. Okay, so you can refer it later. Now
Hmm.
when you talk about interquartile range, the interesting. Okay, so far how many plots have we seen?
4.
Two plots: frequency
Okay.
graph,
Yeah.
right, and scatter
Hmm.
plot. Okay, histogram. We call it histogram. This frequency plot is called histogram. So we have seen histogram and we have seen scatter plot.
Pie chart. Scatter
Pie chart
plot.
also you have seen, correct. So this interquartile range, okay, or sorry, the box plot that you see, okay, is like a box. This is the third graph, okay. So when you talk about data analytics, data science, machine learning, okay, these are the top three plot that you will be that will be useful for analysis: scatter plot, histogram, and box plot. And of course, we're not talking about bar graph, pie chart, those line graph, those are common, right? So those I mean, we don't have to discuss what is bar graph. You have done in your school also, isn't it? Pie chart, bar graph, you must have done in school also,
Yeah.
right? Yeah. So we were at box plot. So box plot, has a box like this, okay, and then it has a handle, okay, and another handle. So this looks like a box, right? Box with two handle, and it will
Yeah.
have a line somewhere here, middle. So this is your Q0, minimum value. Okay, the data set is represented in a box plot using these values. Okay, you have Q0, that is minimum value. Then you have Q1, okay, then you have Q2, which is median,
Medium.
okay, then you have Q3, and you have Q4. Okay, so median is represented by the line between the box. Okay, and box plot is good plot, useful plot, because it will also show you outliers. It will automatically calculate outlier values. Okay, it will automatically calculate outliers value, and it will show you dots. So if you see a dot, okay, that means those are outlier values. So box plot will automatically, identify outliers. Okay. Other plots generally don't, they can't identify outliers. But box plot will identify outliers. And what you call is, it's a horizontal box plot or sleeping box plot. You can even have a standing box plot. Okay, that means what? It means that your numbers are on x-axis. Okay, this is 5, 50, 200, 400, 500. That's what it means. Okay. Number is on x-axis. Numbers can be on y-axis also. Okay. So if number is on y-axis, this is the kind of box you will get.
Yeah.
Horizontal. Is this sleeping or horizontal? Right? This is your vertical or standing.
Hmm.
Okay. I forgot to put median. You'll have median also. Okay, you can draw box plot in either horizontal format or vertical format.
No. You will get noise from that.
Sorry?
You will get no noise from my end,
No, no, no,
from
no.
children.
I'm not
No?
getting noise,
Okay.
but your voice is too low.
Okay.
It looks as if you're talking from far.
No, no, I'm just like attach my Bluetooth. But like in my building premises, now some children are playing, so they are.
Oh, okay, okay.
Uh,
No, no,
so
that's
I
okay.
thought
No, no, no,
you
no, I'm
will.
not hearing any sound.
No?
So, no, no
Okay.
sound. Yeah, okay. Okay, so this is called box plot. You can have, okay, now you can see your plot can be something like this. See, so when you see a long line, right? In the example I gave long line.
Mhm.
What does that mean? What do you think that long line would mean
Yes.
here? Huh?
Uh, there are like more high number on outlier.
Ah, outliers are
No?
represented as dots, right? So do you see any
Uh,
dot here? No. See,
no, I
box
don't know.
plot outliers are represented as dots,
Dots.
right?
Okay.
Do you see any dot there?
No. So
Then
like Q3 and Q4, between them, we have more number of data. Aisa? No?
okay. So
I
see,
don't.
what does quartile mean or median mean? It means that you have equal number of data points, not
Hmm.
value, count. Equal number of count,
No, count.
right? So what it means is the number of numbers, okay? The number of numbers are same, just that range is more. Let's say if this is 5,
Range.
this is 100. So between 5, let's say there are 100 points. That means from 5 to 100, you have 25 values. Okay, this is 100, this may be 120, 120, let's say. And this is 150. And this is 180 or 175. So you see here between 5 and 100, we have 25 values. Here between 100 and 200 only, you have 25 values. So here values are very close to each other.
Hmm.
Here values are very far from each other. Because see, we did quartile means what? Number of numbers like 25, 25, 25,
Yeah.
25. But
Okay,
the
here is
range of
75.
values is more.
Hmm.
Range of values is more.
Yeah, that is
That's
why I
what.
supposed to tell you, but I didn't explain
Yeah,
much
properly.
well.
Okay. 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 So here we're talking about, okay, uh,
Hmm.
um, we're talking about uh, s- sparse kind of thing. Sparse means,
Uh-huh.
lonely numbers. Numbers are very far
Hmm.
off. Okay, that's what it says generally. Okay,
Yeah. Hmm.
okay. So this is what your graph is. I'll just stop here for a couple of seconds. Just see through it.
Hmm. And same as the right side, na? The range, more ranges in right side.
Here
So
it is
that's why
between
the tail
Q0 and Q1. Here it is between
Q1,
Q3 and
yeah,
Q4 on the higher side.
Q4,
Okay,
yeah,
so this is like your positively skewed. You have a long tail. This is
positively
like a
skewed,
negatively
yeah,
skewed.
right
You have a
side,
long tail on the left side of the graph,
left side,
left side of
yeah,
the x-axis.
yeah, you got it.
All right.
Hmm.
Okay, so let's move ahead. Okay. Now look at this data. So this is like box plot of total bill amount. Let's say, on average, these are the bill amount that people pay on Thursday, Friday, Saturday, Sunday. $10 to $50. Okay. So when you look at this, what does it tell you? Take a minute to understand and then tell me. What does this data tell? If I have to ask you to explain this data, how will you explain it?
Okay. So as we can see on Saturday, because it's on weekend, so people are more um like going outside and uh
It does not talk about going outside. It talks about you can't say the number of
bill.
bills. See, more people going out means more people eating out, correct? Here,
Mm.
okay, it will not tell you how many people are going out. Okay, this could be only 50 people. This could be 5,000 people. Possible, right? So you cannot tell how many numbers are there because see, whatever number, uska half hai ye. So if it is 5,000, this will be 2,500. If this is 100, it will be only 50. Correct? So this does not tell you how many numbers are there. So how many people have gone out, that you cannot say from this. Correct?
Okay.
Yes.
But sir, on Saturday the outliers are more because it's above $50.
Yes. Okay. Generally, if you see, the bills on Sunday are higher than any other day. Lower is
So
also higher than the all the lowest, right? And higher is
Sunday. Okay.
right?
I didn't see the lower part. I
You
only
should
see
see the
the
lower,
dots.
right? So if you see
Yes.
here, this
Yes.
is
Now
also
now
higher.
on
So
Sunday.
typically,
Huh.
people spend, not number of people, people spend more on Sunday,
Sunday.
right? And on Saturday, if you see, both are high. Low
Both.
and high both are
Both
more,
are
right? Higher
equal.
is
Yeah.
high and lower is also low. That means, okay, what you can assume is that people generally go out on Saturday, even if they can't spend more, they'll spend little bit,
Yeah.
but they tend to spend.
Hmm.
Unlike your Sunday, where probably people who spend more can spend more only goes out.
Hmm.
But Saturday, almost everybody goes out. Who can spend less and who can spend more. Okay. And typically on Thursday and Friday, people tend to spend lower value on food.
Hmm.
Right? So something like that you can say. Okay. So we have spoken about uh, uh, range and IQR, interquartile range. Okay. Now you have population variance and sample variance. Okay. So we'll talk about variance and then we'll talk about population and sample. Tell me, what is population variance?
Hmm.
Okay, what is variance?
Variance is a difference.
Variance is the okay. So let me show you with data. So we spoke about two car showroom, right?
Yeah.
And let's say this is showroom one, okay, and let's say this is showroom two, okay. So this fellow, okay, is both are saying 30 days, right? Average. So let's say this
Hmm.
is average. We say um, promise date. Okay. So promise date, this fellow is saying 30, 30, 30, 30, 30, 30, 30, 30, 30, 30, 30. Okay. This fellow is also saying 30. But actual what happened? This fellow, is maybe delivering in 10 days. 1 second. Okay. So, okay, so let's say these are your promised date and these are, let's say, actual. So I was talking about actual. So let's say what, okay, so let's say delivered in 10 days, delivered in 40 days. Okay, delivered in again 10 days, delivered in, let's say, 50 days, delivered in 20 days. Okay, 10 days, 10 days, and 40 days. Okay, and this will actually be between 28 to 32, 28, 32, 28, 32, 25, 35, 28, 32, 29. Okay, so this is the date. Now, let's say, okay, we want to see which process is better, which one is better, right? So what we'll do is we'll do the difference, right? Promise minus actual, correct? So let's say this is minus this. So this is the date. Okay. And here also. Okay. So now how can you say which is better? Okay. So look at the
Dif-
difference. So
Difference.
we have multiple values, right? So when you have multiple values, then how do we find single value? We find using central to mean, isn't it?
Mean.
So let's say
Yeah.
we find mean. Okay, so this is called difference, right? And we'll find what is called as mean difference. Okay, so mean difference is what? Average of. Average is 6.
It's
Okay, now here let me see. Mean difference is how much? Uh,
because of these.
okay, now see here, you can easily
0.
say that this is better process because mean difference is 0.1. Now let's say what
0.1.
I'll do is, uh, here I'll do 40. Okay,
Hmm.
and or maybe I'll do 45. And here I'll do 55, let's say. Okay. Now you see, both have mean difference of very less, right? Still, this is better. Okay. This see, mean difference means difference should be closer to 0, isn't it?
Yes.
Okay. But even if, let's say, difference, okay, so let me do one thing to show you. Let's make it uh, 30, 30. Okay. And here, let me make it 30. Okay. Now you tell me which is better. This looks better, right?
First one. First one.
Right? This looks better, correct?
Yeah.
Because mean perfect 0.
0.
Here, mean is minus 0.4.
Negative.
But you see, you're promising 30 days and delivering in 55 days, 40 days, 10 days,
Hmm.
45 days. Here
But
it is all very close to the promised date,
time. Yeah.
right? So average is not giving you a good picture.
Perfect. Yeah.
We need to figure out something which is better than
More perfect.
average. Okay. Now, why
Yeah.
average is not giving good picture? Because this minus and plus is canceling each other.
Yeah.
Okay. So there are two ways to solve this problem. Okay, where average you cannot trust. So there are two ways to solve it. One way is that you find absolute difference. Okay. So difference is
Hmm.
this. Absolute difference is always positive, isn't it? So irrespective of value, okay, is more or less, okay, you will find out positive, absolute only. So let's say I say absolute difference. Okay, in absolute difference, what I'll do, okay, I will say absolute of this value. Absolute. Same thing I'll do here. Okay, absolute. Okay, now you find the difference. Now you see, difference is only 2, but here it is 15. Correct? So you can see that this process is better than this process. You cannot trust mean, right?
Yeah.
Because mean will cancel the positive and negative values. So one way to deal with it is you do the absolute difference. Okay, and then you do the average of absolute difference. So it's called, okay, MAD, mean
That.
absolute difference.
Okay.
Okay,
Hmm.
mean absolute difference. In in machine learning, when we talk same thing, we'll call it as mean
Mad.
absolute error,
Okay.
because it's error there. It is
Yeah.
difference here, it is error in machine learning. That's the error that you see, you expected answer as 10 but you wrote 12, so the error of 2. We call it as MAE there, but in statistics we call it as MAD, mean absolute difference. Okay, so
Okay.
this is one way to look at these numbers. Second way is that, okay, how can we convert negative to positive? So best way to convert is not by doing absolute, okay, but to do square. Absolute,
That.
you are choosing to change some numbers and not to change some numbers. Okay, see, absolute difference will give you some idea, but it is not a good method because you are being very selective. Oh, you are positive, I will not change you. Oh, negative, I will change you. Positive, I will leave you. Negative, I will change you, right? So you are being kind of
Yeah.
selective in your process. So what we'll do is, instead we will calculate square. Okay. Now this is a better way because you are squaring all the values. There's no, you are not selecting it. So I'm saying square of this. So find, doing square is another way of making positive values, negative values positive,
Yeah.
isn't it?
Yeah.
So, and this is better because you are applying the trick or whatever technique you are doing
All
on
all of
all the data,
all of
right?
entire data. Yeah.
Entire data. So now what we
Mm.
do is we will take average of this. We will take average of this.
Average.
Okay,
Yeah.
so average is 5.5, 281.5. So obviously, which is better?
Second one.
Second one is better, right? Same thing we got from first one also. But this value, okay, sometimes we may not trust because of the same reason. Okay, so what we are doing?
Mm. Mm. As absolute difference and then or otherwise square root.
Okay, yes. Okay, and of course you can see now this is called
So
as mean squared. Okay, mean squared difference, or simply mean, sorry, when I say simply, it is variance, I mean. This is your variance.
variance.
Okay, variance is you find the difference and square it and do the average.
Mm.
Okay, average means what? Add all the difference and divide by the number of data
Divided
points.
by yeah.
Okay, this is called, or in machine learning we call it as mean squared error, MSE. Okay, difference is error there. Okay,
Okay.
so this is your variance. But we don't stop here because we started with x and we did x square. So obviously unit are
Yeah.
in they are different unit. You can, it's not apple to apple, right? It's like apple and orange. You started with apple and
Mm-hmm.
then you did apple square, right? So it says, okay, since we have done square, let's perform square root. Okay, so we perform square root of this value to make it in same unit.
Course, yeah.
Okay, we bring it to the same unit. So we perform square root. Okay, this is called as squared mean difference. Sorry, root
Indifference.
mean square difference. We found the
Square
root of
difference.
mean of square difference, or simply standard deviation,
Okay.
or RMSE. Root means squared error. Yes.
Yes.
So see, this is almost in same range, 15, 16.8 to 2.4. Not exactly the same, but it will be in similar range. So that's why we don't generally look at variance. We look at standard deviation, okay, as a standard way of looking at the variability. This is called variability.
Okay.
Okay, this is what I expect. This is what I got. This is what I expect. This is what I got. Variability. This is the variability in the process. Variability is measured in standard deviation.
Okay.
So what is different between population and sample in statistics?
Population में might I don't know, but like with the name suggests, so I thought population में we can do with entire data. In sample में we have collected some sample and
Correct. No, that's right. Okay.
yeah, right?
Now, okay, population means, as yes, you're right. As the name suggests, you're taking the entire population, entire data. Okay.
Yeah.
And in sample, okay, we
Hmm.
are taking part of a population
Some,
and performing all this.
hmm.
Okay. Now you tell me, what did I do? Did I do population variance or sample variance?
You did population.
Yes,
No,
we
no,
did
you did.
population. No, no, we did
Because
population only
hold it.
because we look
Huh.
at the entire data.
Entire data. Yeah.
Okay. I didn't tell you
Hmm.
that there are, thousands of data and we
Yeah.
took sample
Huh.
10. We took entire
Huh.
data. Now let's say, okay, now let's say that this is a sample data. Now I'm telling you that we had, 500 data, but we took only 10 data to understand the data set.
Perform.
So to perform the variance and standard
That
deviation. Okay. Now you tell me in this case, the actual variance, okay, will be more or less. What do you expect? Okay. Obviously, it can be more or less also. It can be less also, it can be more. We cannot say. But what do you expect? Error to
should be
increase or
less.
decrease?
It should be decreased with the samples, with taking some samples.
Okay. So see, when you don't know what is there, that means out of 500, you're taking 10. So you don't know
Hmm.
490 record, right?
Yeah.
So
Right.
your error variance should increase for population. If you're doing a sample, we expect that sample error will be less and population error will be more. That's what we expect.
Hmm.
Because see, if I give you
Yeah.
5 numbers and I tell you predict, you can easily predict. But if I don't give you numbers, obviously there will be error, isn't it? So
Hmm.
how can we reduce the error? How can we increase the error? Because now this is sample. Population we don't know. We don't know because we cannot have all the population data, isn't it? So you have to
Yeah.
make prediction for population. Based on the sample data, you have to make prediction for the population. So if I tell you the sample population is 16.8, then the population's variance, this is standard deviation, right? So if I tell you standard deviation of sample is 16.8, standard deviation of sample is 16.8. So the standard deviation of population will be more than 16.8 or less than 16.8?
Should be more.
Should be more, right? Because we don't
More.
know. When we
More.
don't
More.
know, obviously error will be more.
Yeah.
So to increase the error, there are two things. We can increase the numerator or decrease the denominator. Correct?
Yeah.
So what is the denominator here? Average is divided by n. To increase the error, we divide by n minus 1. Did you understand? Okay. Now, see, the reason I'm doing all these things, I spent some time, is that you don't have to
Mm-hmm.
by heart the formula. You know how you should be able to see the how I derived at standard
How
deviation.
we generate, yeah.
So all these are logical step only, right?
Yeah.
Actual value, so expected value, promise value, or we call them as expected value. Okay. This is what you expect.
Yeah.
When I say average is 30, if you tell me that you run 5 kilometer average every day, then every day I expect you to see that you run 5 kilometer. But someday you will run only 2 kilometers, someday you will run 10 kilometer. So this is actual. This is what is expected average. That's why average value is also called as expected value.
Mm.
Okay. Then you have actual value. This is the difference. Difference, we know the problem because minus and plus gets cancelled. So we do the absolute difference. We find mad. But problem with this is that we are being selective to the numbers. So we do the square. Okay.
Mm. Square
Since
root.
we have done
Yeah.
square, we have to do the square root to get the standard deviation. But when you do this variance, okay, you divide by, okay, not 281.3, but what you do is, so you will take sum of these values, okay, and divide by, okay, 1, 2, 3, 4, 5, 6, 7, 8, right? So if I do 8, it becomes average. I'll do 7. So see, it variance increased. Now standard
Yes.
deviation will be square root of this. So the standard
It
deviation
also is
of
increase.
population is
Also
18
increase.
actually. Okay, is 17.9, whereas of population is 16.8, and sample, if this is sample, then population will be 17.9. Okay,
Yeah.
so difference is that you divide n minus 1 because, okay, we expect the variance to increase for population. Okay, so that's why when you see the data set here, not here, where, here, you see population variance is by n, sample variance is n minus 1. Okay, why n minus 1? To add the error. We know there will be error. There is a mistake, right?
Mm.
Now, let's say when you are estimating the marks, let's say if there are 10 questions, okay, and each of those 10 questions carry 10 marks, okay. So what you
Mm.
do? So let's say you attempted 8 out of 10, correct? So you will not
Okay.
say that you will get 80. You will say that you will get maybe around 70, 75. You cannot get more than 80
Yeah.
because you attempted only 8, right? So you can't get 90 or
Mm.
100 or 81.
Oh,
But you are
right.
introducing that error from your side. Oh, maybe, professor can deduct 1 mark here or there.
Mm-hmm.
So what you'll say, okay, I might get around 70.
Yeah.
You might get 75, you might get 79, you might get even 80, who knows? But obviously you
Mm.
can't get 81.
Yeah.
Okay? But what we do is we try to add that error component from our side. We don't want to be overconfident. We want to add that error component from our side. So we do n minus 1. That's why sample variance is n minus 1. We want to introduce that error.
Yes.
Okay. So this is how you calculate standard deviation variance. I hope that you don't have to by heart. You know how to calculate these values.
Yes. Yes.
Okay. So this is
Yeah.
how we calculate variance and standard deviation. Okay. This is called variability. Okay. And we'll stop here. We'll talk about, we'll go back to our histogram that we did. So when we
Mm.
spoke about mean median mode, we spoke about histogram, which is positively skewed, negatively skewed, or normal
So then,
distribution.
yeah.
Here, when you introduce standard deviation, you might have leptokurtic, mesokurtic, and platykurtic.
Well,
And I'll tell you what each of these things mean in the next session.
Okay.
Sounds good?